Hello, good evening, students. Confirm me the audibility and visibility, please. Good evening, all of you. Welcome to PW platform. Am I audible and visible? Is everything clear? Just ping me. Vivekanand, Prashant Prabhakar, all good, very good, very good. चलिए start करेंगे आज का session. Let's start. So everything is clear. So straight away jump into the topic. So last class the discussion was on algorithm. So let me just define the concept of algorithm and continue from there. We formally defined algorithm as consists of finite set of steps. Finite set of steps or statements to solve a problem. ये तो हम लास्ट क्लास में देखे थे. इसमें I would like to basically make some more additions, right? So please see here on board. Each statement or step consists of one or more fundamental operations. ये हमने लास्ट क्लास में नहीं कहा था, अब यहाँ पे हम डिफाइन कर रहे हैं. Each of the statement or step consists of one or more fundamental, or you may say basic, or you can say primitive operations. आपको शायद पता हो what is the meaning of basic or fundamental operation. उसका example भी दे दूंगा मैं. As an example, if you consider, if I write a high level language statement A is equal to B plus C. This is called a high level statement. इसे हम high level statement बोलेंगे. This high level statement में we have fundamental operations like add, assign. These are fundamental operations. Now this aspect of fundamental operation is essence of time and space complexities. ठीक है? Time complexity particularly dependent on these fundamental operations. So आपको पहचान होना चाहिए अच्छी तरीके से कि हर स्टेटमेंट और स्टेट में फंडामेंटल ऑपरेशन क्या है. So consists of steps, statements consists of one or more fundamental operation. Second aspect, each fundamental operation must satisfy two important property. दो properties satisfy करना चाहिए एक हर fundamental operation. What? Definiteness must be definite, right? That means it should be very clear and ambiguous. It should not lead to any ambiguity. And it should be effective. Effective का मतलब यह है कि it should take finite time to complete. ऐसा ना हो कि कोई ऑपरेशन इज टेकिंग इनफाइनाइट टाइम. या वेरी गुड इवनिंग टू ऑल ऑफ यू अगेन, वेलकम. तो चलिए कंटिन्यू करेंगे क्लास. तो ईच ऑपरेशन, एडिशन हो या सब्ट्रैक्शन हो या मल्टीप्लिकेशन हो या डिवीजन हो या जो भी ऑपरेशन हो, मस्ट बी डेफिनेट, मस्ट बी क्लियर, अनएम्बिगुअस एंड मस्ट बी इफेक्टिव. इफेक्टिव का मतलब है कि इट शुड कंप्लीट इन फाइनाइट अमाउंट ऑफ टाइम. अगर वो फाइनाइट अमाउंट ऑफ टाइम में कंप्लीट हो रहा है तभी आपका एल्गोरिथम टर्मिनेट होगा फाइनाइट टाइम में, क्योंकि one of the important property of algorithm ये है कि it should complete in finite amount of time. Finite amount of time में complete होना चाहिए. वो तभी possible है जब आपके operations effective हो. ठीक है? Next aspect is every algorithm may accept zero or more inputs, externally provided inputs, but must produce at least one output. ये बहुत जरूरी है. अगर मान लीजिए algorithm is not producing any output, then we don't know whether algorithm is right or wrong. हमें कैसा पता चलेगा कि algorithm is achieving its desired objective or not? That's why must produce at least one or more output, but may accept zero or more externally provided input. This is the formal definition of algorithm. नेक्स्ट हम देखेंगे व्हाट आर द लाइफ साइकिल स्टेप्स. जनरली लाइफ साइकिल हम बोलते हैं या लाइफ साइकिल स्टेप्स फॉर program development or algorithm development. ये based on these steps only I would like to project to you what is the scope of this subject. ठीक है? So first we will have the problem definition. ठीक है? You will define the problem for which you want to develop the algorithm. Then you basically determine the requirements. Every problem will have its requirements to be satisfied. क्या क्या requirements है problem के? हर problem के अपने own requirements होते हैं. Generally in the software engineering terminology आप इसे बोलेंगे SRS, software requirement specifications. In algorithmic terminology this is also called constraints. हर algorithm के अपने constraints होंगे, requirements होंगे, वो find out करेंगे आप. फिर after the requirements have been identified, you think of the design, you think of the logic, the mechanism. क्या logic होना चाहिए, कौन सा design होना चाहिए for solving your problem. Then fourth step you say you express your design, express the design in the form of either algorithm or maybe in the form of flow chart. तो ये statement पे और ये step पे आप बोलेंगे algorithm development. यहाँ पर आप algorithm अपना develop कर रहे हो, express the design, either in the form of algorithm or in the form of flow chart. फिर उसके बाद क्या करेंगे आप? उसके बाद आप validation करेंगे. You validate. आपका algorithm develop हो चुका, अब आप validation करेंगे, prove the correctness or incorrectness. Generally people confuse between validation and testing. देखिए दोनों में फर्क है. Testing is done of program, validation is done of algorithm. Validation का मतलब यह है कि whether your algorithm is meeting all the requirements which have been isolated in step 2 or not. That is validation. Proving correctness or incorrectness. ठीक है. After that you think of analysis. You go for analysis. Why should we analyze? अभी हम वो question address करेंगे shortly. After analysis is done, you will go for implementation. Use some language, convert the algorithm into program, take some hardware, run it on the machine, right? That is implementation. And finally, test and debug. Testing and debugging. So in general, these are the steps that we generally follow as life cycle steps. तो इस स्टेप्स में मैं आपको ये बताना चाह रहा हूँ, जो हमारा कोर्स है डिज़ाइन एंड एनालिसिस ऑफ एल्गोरिथम, DAA जब हम बोलते हैं, तो पर्टिकुलरली फ्रॉम दीज स्टेप्स वी आर प्राइमरली इंटरेस्टेड इन स्टेप 3 एंड स्टेप 6. जब हम डिज़ाइन की बात करते हैं तो कौन सी डिज़ाइन स्ट्रैटेजी हम यूज़ करेंगे फॉर सॉल्विंग दिस प्रॉब्लम. So that means as an algorithm developer or as an algorithm analyst, you should be knowing all the design strategies. Design. जब आप डिजाइन कर लोगे algorithm, एक implement algorithm को आप express कर लोगे, then finally you analyze it. Why should we analyze? Maybe to find the most efficient algorithm for the given problem, right? So that is the scope of this subject. So from these life cycle steps हम बोलेंगे कि we are interested in this course, the design aspect and the analysis. तो चलिए आगे बढ़ के देखेंगे what is the need for analysis. जैसा मैंने last time भी आपको बताया था, we will address the question of need. Why should we analyze? Addressing the question of why. Need for analysis. Just before I continue, can you just write down in the chat box, let me see whether you are knowledgeable or not. आप पता है या ना? आप just a couple of words में लिख के बताइए, what is the reason for analysis? Why should we analyze? Come on. Just write in a couple of statements and tell me what is the need for analysis. Bharat Pandey, there are so many people. Satyam B. Nayak, Bhagwadari, KTZ. Tell me, what is the reason for analysis? Why should we analyze? You understand complexity? Ankit Singh, no? What do you mean by complexity, first of all? That is another question. Simple reasons, simple language में बताइए कि analyze क्यों करेंगे हम? We want to know the time of statement execution, we get to know thought, okay? Check for algorithm whether it is right or wrong. See, check for algorithm whether it is right or wrong, वो validation है, not analysis. So that we can make better algorithm. ठीक है, efficient way to solve. To know time and space, correct? Yes, Rahul Kumar is saying resources need. Very correct. Resource consumption. Arpan Paul. Yes, that is what I generally teach. I generally say. That's what I wanted to basically check out. Yes, there are two basic reasons. I will put it like this. There are two basic reasons for doing this analysis. One is to determine the resource consumption by the algorithm. कितना रिसोर्स, कितने और क्या रिसोर्सेस कंज्यूम कर रहा है. तो आप यहां पर एक डाउट आएगा कि सर व्हाट आर द रिसोर्सेस. द रिसोर्सेस विल वेरी फ्रॉम प्लेटफॉर्म टू प्लेटफॉर्म, from computing environment to computing environment. Primarily for most of the computing environments, the important resources are time and space. Right? Time and space. Time of CPU maybe and space of memory. ये बहुत critical resources है दोनों computing environment के. How much time the algorithm take to terminate to solve the problem, and how much memory space that does it consume? Right? So determining the time, determining the space, in other words, you may also call it as time complexity and space complexity. But I would like to make a mention, यहाँ पर एक बात आपको ये बताना चाह रहा हूँ मैं कि don't think that analysis means we analyze only time and space. ये बहुत important point है. People often feel, often see, often observe that when they say analysis, they analyze only with respect to time and space. नहीं, you can analyze with respect to other resources. फिर other resources क्या होंगे? That, as I said, depends on the computing environment. अगर आप बात करेंगे मोबाइल कंप्यूटिंग की, वहां पर इंपॉर्टेंट रिसोर्स आपकी हो जाएगी पावर, एनर्जी. अगर कोई सिस्टम सॉफ्टवेयर डेवलप कर रहे हैं जैसा कंपाइलर्स है या अदर सिस्टम प्रोग्राम्स है, वहां पर आपका रिसोर्स बन जाएगा रजिस्टर बिकम इंपॉर्टेंट रिसोर्स. फिर अगर आप डिस्ट्रीब्यूटेड कंप्यूटिंग एनवायरनमेंट जाएंगे या नेटवर्क एनवायरनमेंट जाएंगे, वहां पर आपका इंपॉर्टेंट रिसोर्स बन जाएगा network, channel capacity, bandwidth. These are the resources. So therefore, our objective is to basically concentrate on personal computing domain. So from personal computing domain perspective, the important resources are time and space. अगर आप मोबाइल डेवलपर है तो you need to have an environment to determine the energy consumption. इसीलिए मोबाइल environment में आप you will find the research papers saying power aware routing. Power aware, they use the word power aware. मतलब they are trying to develop algorithms which are efficient with regard to power consumption, energy consumption. ठीक है, मोबाइल एनवायरनमेंट्स में. डिस्ट्रीब्यूटेड एनवायरनमेंट में आप you would like to minimize the consumption of the channel capacity, the bandwidth consumption. तो उस तरीके से the personal computing areas में important resources are time and space. ठीक है, आप टाइम डिटरमिन कर लेंगे, स्पेस भी डिटरमिन करेंगे, उसके बाद क्या है? What is the other reason? The other reason is the basic primary reason for analysis. The other basic reason is to make what we call performance comparison. Performance comparison. This is the main reason for analysis. Compare the performance of different algorithm for solving a problem. I don't have to tell you boys and girls, आपको पता है कि for a given problem P, कोई भी एक प्रॉब्लम P के लिए I can have multiple algorithms. Is it not? कई algorithms हो सकते हैं using different strategies, different approaches. Let's say I have algorithm A1, algorithm A2, algorithm A3. A problem has 3 solutions, but let us say. जब 3 solutions होंगे तो obviously कोई भी पूछेगा sir which is the best, which is the most efficient. कोई भी पूछेगा. तो आप कैसे डिटरमिन करेंगे कि among A1, A2, A3 which is the most efficient solution? आप तभी डिटरमिन कर पाओगे जब आप परफॉर्मेंस कंपैरिजन करोगे इन 3 एल्गोरिथम्स का. और नेचुरली आपको परफॉर्मेंस कंपैरिजन करने के लिए आपको कोई रिसोर्स चाहिए, कोई पैरामीटर चाहिए. या तो आप लेंगे टाइम या तो आप लेंगे स्पेस और बोलेंगे सर विथ रेस्पेक्ट टू टाइम मे बी दिस इज बेटर, विथ रेस्पेक्ट टू स्पेस मे बी दिस इज बेटर. So you have to make a comparison between them to find out the most efficient algorithm. Right? So that can be done only by making performance comparison among the different algorithm with respect to the metric time or space. So this is the reason for carrying out analysis or doing analysis. So number one, to determine the resource. ठीक है, resource determine करके क्या करोगे आप? To make a performance comparison to find out the most effective or efficient solution for my given problem. That's it. This is the need for analysis. तो जब बात समझ में आ गई कि what is the need for analysis, तो नेक्स्ट ऑब्वियसली क्वेश्चन आएगा कि हाउ टू डू द एनालिसिस, हाउ टू एनालाइज, हाउ टू डिटरमिन द रिसोर्सेस, हाउ। नेक्स्ट क्वेश्चन होगा हाउ, मतलब आप कैसे टाइम डिटरमिन करोगे, कैसे स्पेस डिटरमिन करोगे। तो वो क्वेश्चन हम एड्रेस करते हैं इन द टॉपिक मेथोडोलॉजी ऑफ एनालिसिस। ठीक है, मेथोडोलॉजी, अप्रोच। तो जैसे आपको पता है मैं जनरली क्रैश मोड में है, दैट्स व्हाई आई एम ट्राइंग टू जस्ट कवर अप द कॉन्सेप्ट्स। देयर आर टू मेथड्स, देयर आर टू मेथड्स ऑफ एनालिसिस। द फर्स्ट वन इज कॉल्ड a posteriori मेथड। इसे हम जनरल टर्म में बोलेंगे एक्सपेरिमेंटेशन एनालिसिस, एक्सपेरिमेंटेशन अप्रोच। इन अदर टर्म्स दिस इज प्लेटफॉर्म डिपेंडेंट। अभी बोलूंगा मैं व्हाट इज द मीनिंग ऑफ प्लेटफॉर्म। प्लेटफॉर्म डिपेंडेंट। द सेकंड अप्रोच इज ए प्रियोरी एनालिसिस। दिस इज प्लेटफॉर्म इंडिपेंडेंट। To understand what is a posteriori analysis or what is a priori analysis, we can start with a simple example. Like if I write a high-level language statement like x is equal to y plus z, please follow me. If I write a statement x is equal to y plus z, and if I ask you how much time does it take, मैं अगर पूछूं कि कितना टाइम लगेगा, तो in a posteriori analysis, post का मतलब है बाद में, that means after converting this statement into program, after running it on the machine processor, right, using some language, using some operating system. So when I say platform, I am essentially referring to two aspects. One is hardware and the other is software. Hardware मतलब CPU speed है, memory speed है, and so on. Software is again into two parts, operating system and programming language, PL, is going to affect the time, is going to affect the efficiency. Okay? So if you implement your algorithm using some language and use some operating system and run it on the machine and determine how much is the time needed, how much is the time taken, such type of analysis is called a posteriori analysis. That is why it is called platform dependent analysis. So it is very obvious, agar different people use different processors, different platform, so obviously हर एक का टाइम अलग अलग होगा, हर एक का टाइम अलग अलग आएगा. अगर मान लीजिए किसी का प्रोसेसर फास्ट हो, मेमोरी फास्ट हो, उसका टाइम लेस होगा, किसी का प्रोसेसर स्लो है, उसका टाइम ज्यादा होगा. Some languages are going to generate more efficient code, some languages do not generate efficient code. कोई ऑपरेटिंग सिस्टम मान लीजिए प्रीएम्प्टिव होगा, कोई ऑपरेटिंग सिस्टम नॉन प्रीएम्प्टिव होगा. इवन इफ हार्डवेयर इज सेम, अगर आपका सॉफ्टवेयर चेंज हो रहा है, प्लेटफॉर्म चेंज हो रहा है, ऑपरेटिंग सिस्टम, तो फिर भी टाइम डिफरेंट हो सकता है. सो दैट इज वाई इन व्यू ऑफ दिस we don't prefer to carry out analysis in a posteriori mode. This is not preferred. It is not preferred. क्यों प्रिफर नहीं करेंगे हम? Even though it is going to give you the exact value in units of time, maybe in millisecond, nanosecond, microsecond में आपका टाइम आएगा, लेकिन हम ये एनालिसिस प्रिफर्ड नहीं करेंगे. क्यों? There are reasons for that, as I said. Number one, it is difficult to carry out the experiment. ये आसान नहीं है. Is dependent on the platform. Second, it makes the performance comparison difficult. अभी मैंने कहा एक आध बंदा रन करेगा कोई एक फास्ट सिस्टम पर, कोई बंदा रन करेगा स्लो सिस्टम पर, दोनों के टाइम्स डिफरेंट हो गए. इट बिकम डिफिकल्ट फॉर मी टू मेक कंपैरिजन अमंग देम टू फाइंड आउट विच इज द मोस्ट एफिशिएंट एल्गोरिथम. और ऐसा भी हो सकता है किसी का एल्गोरिथम एफिशिएंट हो, लेकिन उसका प्लेटफॉर्म जो प्रोसेसर है वो बहुत पुराना प्रोसेसर हो, बहुत स्लो प्रोसेसर हो, वो ज्यादा टाइम लेगा. और किसी का एल्गोरिथम इनएफिशिएंट है लेकिन फास्टर सिस्टम पे रन करने की वजह से वो कम टाइम लेगा. तो देयरफॉर डिपेंडेंसीज है, नॉन यूनिफॉर्मिटी हो जाएंगी वाली वैल्यूज में. तो देयरफॉर इट बिकम डिफिकल्ट टू मेक परफॉर्मेंस कंपैरिजन. So comparing the efficiencies become difficult if I carry out analysis on a posteriori mode. So point number one, it is difficult to carry out. Point number two, it makes performance comparison bit difficult. Third reason is for not preferring a posteriori analysis is experiments can be carried out on a limited set of inputs. पूरे inputs पर आप नहीं कर सकते experiment. Limited set of inputs. And care must be taken to make sure that all the inputs are representative. मतलब जो भी आपके typical inputs है वो पूरे आप use करना चाहिए in order to carry out. So that is the reason why we don't prefer a posterior analysis. Yes, Qadir, I told you, it gives you the only advantage of a posterior analysis is that it gives you exact value. लेकिन अब मैं आपको बताना चाह रहा हूं, in order to make performance comparison of multiple algorithms, I don't need exact values. मुझे अगर estimated values या approximate values भी अगर मिल रहे हैं तो मुझे काफी है to make performance comparison. That is the reason I don't prefer a posteriori analysis. So we prefer in this regard a priori analysis. Prior का मतलब है before. Prior का मतलब है before. Before what? Before implementation. Before implementation. Before execution on the machine. जो आप analysis करोगे उसका नाम है a priori analysis. Right? A priori analysis. इसकी main characteristic हमने जैसा अभी देखा platform independent. That means it is not dependent on any platform. It is not dependent on any architecture. It is not dependent on any hardware or software. लेकिन फिर भी एक हमारे पास एक मैथमेटिकल का मॉडल होना चाहिए, एक कंप्यूटेशन मॉडल होना चाहिए within which the algorithm is assumed to work, assumed to execute, right? So that we can determine the time. तो हम कैसे करेंगे? So therefore we always perform a priori analysis. जब हम समझ गए कि a priori analysis का इंपॉर्टेंस क्या है, तो अब हम देखेंगे how to carry out a priori analysis. ये एनालिसिस कैरी आउट करने के लिए एक 4 चीजें हैं, 4 थिंग्स यू हैव टू कीप इन माइंड. नंबर 1, यू हैव टू यूज सम लैंग्वेज. नंबर 1, यू हैव टू यूज सम लैंग्वेज. दैट मीन्स यूज सम सूडो कोड, सूडो लैंग्वेज टू एक्सप्रेस योर एल्गोरिथम. जैसे मैंने एक लिखा स्टेटमेंट A इज इक्वल टू B प्लस C. ये एक पर्टिकुलर लैंग्वेज है, सूडो लैंग्वेज है, फॉल्स लैंग्वेज है, जहां पर आप पूरे एल्गोरिथम के स्टेप्स लिखोगे. Right? Express your algorithm using some pseudo language. Right? Let us assume some existence of computational model, computational machine, model or machine, mathematical model of a computer, जिसे हम बोलते हैं RAM model, within which algorithm executes. Within which algorithm executes. इसका मतलब ये है, we are assuming that we have a processor. बहुत important point है, please keep in mind. We are assuming a mathematical model of a computer, right? Mathematical model of a computer, right, which is having a processor with a characteristic that ये processor पे हर एक statement, हर एक operation, every fundamental primitive operation takes 1 unit of time. मैं यहां पर यूनिट बोल रहा हूं. मैं यहां पर यह नहीं कह रहा हूं कि सेकेंड हो या मिली सेकेंड हो या नैनो सेकेंड हो, माइक्रो सेकेंड हो. 1 यूनिट ऑफ टाइम एवरी ऑपरेशन. तो अब आप बोलेंगे सर प्रिमिटिव ऑपरेशंस क्या है? यहां पे थोड़े एग्जांपल्स हम लिख लेंगे प्रिमिटिव ऑपरेशंस के, क्योंकि एल्गोरिथम स्टेटमेंट कंसिस्ट ऑफ फंडामेंटल ऑपरेशंस. तो दीज प्रिमिटिव ऑपरेशंस कैन बी लाइक अरिथमेटिक ऑपरेशंस, अरिथमेटिक लाइक एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन एक्सेट्रा. लॉजिकल ऑपरेशंस भी हो सकते हैं, लाइक फॉर एग्जांपल एंड है, और है, राइट, नॉट है, एक्सेट्रा. या डेटा ट्रांसफर ऑपरेशंस भी हो सकते हैं. आप ट्रांसफर कर रहे हो डेटा, मूविंग फ्रॉम रजिस्टर टू रजिस्टर, मेमोरी टू रजिस्टर, मेमोरी टू रजिस्टर टू मेमोरी, डेटा ट्रांसफर. या फिर आपके रिलेशनल ऑपरेशंस भी हो सकते हैं, कंपैरिजन, you are comparing two values. These are examples of primitive operations. तो हम ये यहां पर मान के चल रहे हैं कि every fundamental operation on our RAM model of computer will take 1 unit of time. That's it. तो ये बात, this is the foundation for our analysis, a priori analysis. Every basic operation, every primitive operation is going to take 1 unit of time, and we assume that we have infinite capacity of memory to store all our algorithmic statements. There is no shortage of any memory. This is the RAM model. तो हम ये RAM मॉडल में अज्यूम कर रहे हैं कि अवर एल्गोरिथम स्टेप्स आर स्टोर्ड हियर. एक एक स्टेप के कई ऑपरेशंस हम एग्जीक्यूट करेंगे और हम टाइम डिटरमिन करेंगे. सो दिस इज द बेसिक ऑफ द कॉन्सेप्ट. थर्ड, वी आर गोइंग टू यूज सम मेट्रिक, परफॉर्मेंस मेट्रिक बोलेंगे हमसे. मतलब एक ऑपरेशन होगा एक ऑपरेशन होगा, राइट, परफॉर्मेंस मेट्रिक बोलेंगे, प्रिमिटिव ऑपरेशन है, दैट इज गोइंग टू कैरेक्टराइज द रनिंग टाइम ऑफ द एल्गोरिथम। जैसे कि एग्जांपल दूंगा मैं, अगर हमारा एल्गोरिथम है सर्चिंग एल्गोरिथम, तो सर्चिंग एल्गोरिथम में प्रिमिटिव ऑपरेशन क्या होना चाहिए? प्रिमिटिव ऑपरेशन होगा कंपैरिजन, राइट। अगर मैट्रिक्स मैनिपुलेशन है तो शायद प्रिमिटिव ऑपरेशन होगा एडिशन सब्ट्रैक्शन, ठीक है। या कोई एल्गोरिथम में प्रिमिटिव ऑपरेशन होगा, या मेट्रिक हो गई, मे बी डेटा मूवमेंट ऑफ डेटा, या असाइनमेंट ऑपरेशन होगा। तो उसी तरह हर एल्गोरिथम में आपको ये एक बेसिक फंडामेंटल परफॉर्मेंस मेट्रिक, इट मींस दिस इज नथिंग बट फंडामेंटल ऑपरेशन, which is going to characterize the running time of algorithm. This you have to identify, this you have to determine. फिर उसके बाद लास्ट स्टेप है a priori analysis का, you are going to characterize the time with respect to some framework. representation है टाइम का, यहां पर हम बोलेंगे asymptotic notation. The asymptotic notation is only a tool, basically, is only a part of a priori analysis. It is used to characterize the running time of algorithm, including recursive algorithms. It's a tool to characterize the running time of algorithm. The actual steps are these: you have to basically express your algorithm using some language, you assume some computational model, and then identify the metric, and then determine the step count. After determining the step count, फिर आप जब asymptotic notation use करेंगे to represent the time in a most suitable and beautiful way. That is the basic rule. तो अब ये हम समझेंगे, all these steps we'll try to understand by taking a simple example. So I'll take a hypothetical मतलब non-existing or maybe not that meaningful. We'll call the algorithm as test, something like this. It has the following steps: x is equal to y plus z, step A, or we'll write step 1. Step 2, I write a loop for I is equal to 1 to n, where maybe n is my integer input, let us say, like this. Right? Here I will write like a is equal to b star c, something like this. Third step, I write another loop for I is equal to 1 to n, for j is equal to 1 to n. ठीक है? I write some k is equal to k star 3, something like this. These are the 3 steps of the algorithm. And I want to know what is the time taken by this algorithm, what is the time needed by this algorithm in a priori mode. A priori mode. दो approaches से मैं आपको बताऊंगा, एक shortcut and the regular approach. The regular approach is determine the step count. Step का मतलब operation, fundamental operation, primitive operation, basic operation, count of number of operations. हमने अभी कहा each fundamental operation is going to take 1 unit of time. तो हम क्या करेंगे? total operations determine करेंगे, total count measure करेंगे, that is nothing but the algorithm time. That's it. देखें अब यहाँ पर first step, इसका step count क्या है? So if I consider this algorithmic step having two fundamental operations, addition, assignment. The question is, in this statement, how many additions and assignments are taking place? One addition, one assignment. So this is going to take 1 unit, this is going to take 2 units. Nothing wrong if you write the total time taken by this step is 2 units. ठीक है? Is going to take 2 units of time. That's it. चलिए, step 1 हो गया. Step 2, अब ये step जो composite step है using a loop, what is the step count of this? तो इसके लिए हमें ऑपरेशंस आइडेंटिफाई करने हैं. क्या है ऑपरेशंस? लेट अस सी. फर्स्ट इज इनिशियलाइजेशन. I is initialized to 1. If you consider that as one operation, I will write time is 1 unit plus. Now, next you compare the value of I with n. How many times the value of I is compared with n? N plus 1 times we make the comparison. I is equal to 1, then 2, then 3, then when I become n plus 1, when it becomes greater than n, you come out. So therefore, n plus 1 comparisons. What is n? Input. N is input. We are incrementing the value of I. I is incremented to 2, 3, 4, 5 up to n, for example. So therefore, n times you are incrementing. Initialization, comparison, updating I. फिर internally आप देखिए multiplication. Per iteration, this multiplication is done 1 time. टोटल आइट्रेशंस कितने होंगे ये लूप के? n आइट्रेशंस होंगे, तो देयरफॉर प्लस n मल्टीप्लिकेशंस। फिर असाइनमेंट इज ऑल्सो ए फंडामेंटल ऑपरेशन। फिर आप असाइनमेंट चेक कर लीजिए कितने बार पर आइट्रेशन इट इज डन वन टाइम, एंड नंबर ऑफ आइट्रेशन दिस फॉर लूप इज गोइंग टू रिपीट इज n आइट्रेशंस, so therefore n assignments। मैं यहां पर ये मान के चल रहा हूं कि यू नो हाउ दिस फॉर लूप वर्क्स, राइट? You know it. First you do the initialization, then you compare it. If it is less than, and then I execute this, then again increment I, then again compare, like that it goes. Is it clear? So I say that the total time taken by my step 2 is these many units. तो अगर आप इसको ऐड कर लेंगे तो I have 1 2 3 4 4n plus 2. It's a function, mathematical function in terms of n. So 4n plus 2 units is the total time taken for step 2. 4n plus 2 is the total units of time taken for step 2. अब step 3 पे आ जाइए. What is step 3? How much time does this take? तो पूरे statements आप पूरे fundamental operations sequentially identify करना होगा, right? So before I tell, can you write? Let me see. Just I'll give you 2 minutes of time. Ajay Yadav, I am not at all knowledgeable with what you are telling. Kindly don't spam here, right? Don't spam. I believe that you are all very knowledgeable and judicious enough. So don't spam. Things which I don't know, I cannot answer. Don't continuously put the messages. Ajay Yadav, concentrate on the subject. Look at this. Can you write? Let me see. Just like this equation 4n plus 2. Let me see how many of you are knowledgeable. Can you tell me what is the total step count of statement 3? Total step count. एक function के लिहाज से लिख के बताइए. What is the total step count of step 3? Come on, boys and girls, work out and tell. यहाँ से आपका fundamental working start होगी. So you can test with respect to this whether you can do it or not. Adir is saying 4n square plus 4n plus 2. Okay, others? Come on, other people also, please work out and tell. What is the step count of step 3? Rahul Kumar, 4n plus 2. 4n plus 2 कैसे होगा? सोचिए आप. Rasiqur Rahman, 6n plus 2, no. Bhagwadari, 4n square plus 2, no. 5n plus 4, no. Check it. Essentially आपको understand ये करना है कि what exactly are the fundamental operation and how many times the fundamental operations are executed. That is what you have to see. Come on, others also, please work out. Overall, yes, overall you have to tell. 4n square plus 2 plus 4n plus 2, no. चलिए स्टार्ट करेंगे. ठीक है. Initialization I is equal to 1 done one time, plus comparing I with n is done n plus 1 time, plus incrementing I is done n times, plus boys and girls be careful. यहाँ पर student confuse हो जाते हैं. Be careful, I am drawing your attention. Initializing j is equal to 1 is done first time only one time, right? When I enter the loop for the first time it is done one time. लेकिन this loop is repeating for n times. So this initialization of j is equal to 1 is done n times. यहाँ पे लिख रहा हूँ मैं n times. This n time is the initialization of j is equal to 1. देखिए आप, per iteration of I, j is compared with n plus 1 times. Per iteration, again I am repeating. Per iteration j is compared with n plus 1 time, and total number of iterations that it is making is n. So therefore n into n plus 1. N into n plus 1 is the total number of times that this comparison between j and n takes place in the whole for loop of I. Whole for loop of I. This you have to be careful. Generally यहाँ पर people make mistake. N into n plus 1. ठीक है. उसी तरह per iteration we are going to increment j n times. So our total number of iterations are n. So updating the value of j is done n into n times. N square times. Plus अब internal आ जाइए. Multiplication of this total number of time that this is done is n. So for one iteration of I, this is done n times. How many iterations of I have? N. So therefore this is done n into n times. Multiplication of k into 3 is done n into n times. Plus this assignment of the value is also done n into n times. ये हो गया मेरा total step count. This is the actual approach of doing. Identifying in every fundamental operation and making a count. That's it. This is a total procedure, actual procedure. Shortcut I will tell you shortly. इस तरीके से actual करेंगे. So actually n square कितने terms से देखिए आप, ये रहा 1n square, 2n square, 3n square, 4n square. So therefore 4n square plus n कितने हैं 1, 2, 3, 4. 4n I have. Constants कितने हैं 1, 2, 2. That's it. So this is my function. 4n square plus 4n plus 2. Got it? This is the function representing the units of time for step 3. These are the units. So total time of the algorithm कितना हो जाएगा? Total time of the algorithm कितना हो जाएगा? Time is nothing but sigma of all the steps. Time is sigma. So if I represent time by means of a function like t of n, for example, is nothing but sum of step 1, time of step 1, plus time of step 2, 4n plus 2, plus time of step 3, 4n square, plus n, 4n plus 2. So if you add together, it become 4n square plus 4n plus 4n, 8n, plus 2 plus 2 plus 2, 6. This is what I call the total time taken in units based on a priori analysis. This is how I get time of step 1, step 2, step 3. 4n square plus 4n plus, 8n plus 6. This is the total time. Okay, this is the approach. We have a shortcut method which is called order of magnitude. Generally, I tell the student to follow that also for determining, rather than doing this in a very intricate way, in a detailed way, you can apply something called order of magnitude concept to represent the time in a similar way. Order of magnitude of statement. Every statement will have what is called order of magnitude. Order of magnitude refers to the frequency, the count of the basic or fundamental primitive operation in that statement. So for statement 1, x is equal to y plus z, basic operation is addition, assignment. So how many times frequency, how many times this addition is done, how many times this assignment is done. So for statement 1, I say the order of magnitude is 1, frequency, count. उसी तरह statement 2 का हम metric find out कर लेंगे, basic operation कर लेंगे, या तो आप multiplication लोगे या assignment लोगे. This is only for control purpose, initialization, incrementing I, comparison I. That is not the basic objective. The basic objective is to multiply or assign. How many times this multiplication is done? It is done n times. How many times this assignment is done? N times. So I say the order of magnitude of second step is n. And order of magnitude of step 3. Again, the basic operation is multiplication or assignment. So how many times that is done? That is done n square. So add the two functions, n square plus n plus 1. Relatively, the type of function of both are same. Here I have some constants, here I don't have, right? So this is my function t of n representing the time based on order of magnitude. So either you can follow this methodology or this methodology. Ultimately, जब हम asymptotic notation यहाँ पर apply करेंगे, both will give you the same order, whether this function or this function. So I always advise the students, instead of saying, अगर आपको कुछ order of magnitude में difficulty हो रही हो, तब आप step count पे जाइए, वरना आप order of magnitude पे direct just look at the statement, tell the order of magnitude and simply write the function. तो यहाँ पर आपको ये बताना चाह रहा हूं कि a priori analysis में you are going to represent the time. The basic objective of a priori analysis is to represent the time by means of a mathematical function. By means of a mathematical function like this or this, in terms of or with respect to input size. Size of the input. What is that? N. N is your input. So with respect to input size, you are going to represent the time by means of a mathematical function. That mathematical function is showing the behavior of the algorithm with respect to input. Right? कैसे behave हो रहा है? Does it follow a quadratic growth, does it follow a linear growth? Does it follow a logarithmic growth? Does it follow exponential growth? So the basic objective is to represent the time by means of a mathematical function of input size with a natural convention के जैसा आपका input grow होगा, जैसा आपका input increase होगा, time increase होगा, तो you are trying to show the rate of growth of time, कैसा time grow हो रहा है with respect to input size in terms of a function. That's it. This is the basic objective of a priori analysis. आपने देखा होगा यहाँ पर आपको a priori analysis करने के लिए आपको ना कोई मशीन चाहिए, ना कोई लैंग्वेज चाहिए, ना कोई ऑपरेटिंग सिस्टम चाहिए. जस्ट एक पीस ऑफ पेपर पे आप एल्गोरिथमिक स्टेप्स लिख लीजिए, ऑर्डर ऑफ मैग्नीट्यूड डिटरमिन कर लीजिए, एंड देन यू कैन बेसिकली वर्क आउट दैट. ठीक है, यू कैन अप्लाई, आई मीन यू कैन गेट ए मैथमेटिकल फंक्शन. चलिए, मैथमेटिकल फंक्शन तो आ गया. अब यहां पर हम अंडरस्टैंड करेंगे कि भाई असिम्प्टोटिक नोटेशन का रोल क्या है. नंबर वन रीजन इज, सी यहां पर तो 3 स्टेप्स थे एल्गोरिथम में, हमने 3 टर्म्स लिख लिया, इट इज ओके. लेकिन अगर मान लीजिए मेरे एल्गोरिथम में 10,000 स्टेप्स हैं या 1 लाख स्टेप्स हैं, देन माय टाइम कॉम्प्लेक्सिटी फंक्शन टी ऑफ एन मे हैव 10,000 टर्म्स. तो हम बोलेंगे टाइम कॉम्प्लेक्सिटी इज रिप्रेजेंटेड बाय 10,000 टर्म्स, ए फंक्शन with 10,000 terms, which looks very clumsy, which looks very awkward, right? Not desirable to show the time in that way. So in that regard, this asymptotic notation ASN comes to our rescue by characterizing the time in a most suitable and representative way, right? In the form of its notation, either big O or omega or theta. Second reason for using asymptotics. See, यहाँ पे point मैं ये लिख रहा हूँ, asymptotic notation ASN is basically a tool, mathematical tool, to determine the bounds on functions. Mathematical functions. Generally, there are 3 bounds a function can have. One is definitely upper bound, the other is lower bound, and the third is tight bound. Any mathematical function can have 3 bounds. अपर बाउंड का वो मतलब वो है दैट फंक्शन विच इज हैविंग ए वैल्यू ग्रेटर देन इट और इक्वल टू मे बी. लोअर बाउंड का मतलब इट इज हैविंग ए लोअर वैल्यू. एंड टाइट बाउंड विल कम इनटू पिक्चर व्हेन बोथ अपर एंड लोअर बाउंड हैव द सेम रिप्रेजेंटेशन, सेम फंक्शन. We'll define that, right? So since our time, now you say, so this is actually applicable to mathematical functions. तो आप यहाँ पूछेंगे कि sir, then why are we using it in analysis of algorithm? The reason is simple. Since we are representing time, look at this. We are representing time by means of a mathematical function. So therefore we can apply asymptotic notation on these mathematical functions representing the time to basically represent what is the upper bound time of the algorithm. Maybe you can say maximum. What is the lower bound time of the algorithm? Maybe the minimum time the algorithm take for that case of input, and what, if applicable, tight bound. So that's the reason why I apply asymptotics to time complexities. The time complexity, determining the time is not asymptotic notation, please. Asymptotic notation is only playing a role in a priori analysis by way of characterizing the running time, right? In terms of some notation, upper bound means maximum time, lower bound means minimum time perhaps, etc. Okay, so for that we have these notations. So these asymptotic notations, ASN, I write generally in short, basically classified into 2 types. We have big notations and small notations. Small also called little. There are 3 big notations. We have big O, represented by capital O, used for upper bound of a function. Then we have big omega, right, represented by this Greek symbol, lower bound of a function, representing lower bound. And third we have theta, represented by the Greek symbol theta. This is for, we say, tight bound. And we have 2 small notations, small o, represented by small case o, for representing proper upper bound, and small omega, proper lower bound. The Greek symbol for small omega is this, proper lower bound. These are the 5 notations. So my appeal to you is that, of course, I am going to give quick definitions of these in our examples, and then I will take up some problems. We'll work out some problems on this. But my appeal to you is basically that make yourself well familiarized with the concept of asymptotic notations or definitions of asymptotic notations. वो बहुत important है. चलिए, quickly we'll try to define the asymptotic notations, starting with first big O. Big O, represented by capital O, used to represent the upper bound or get upper bound or apply upper bound on a function. Of, or you can say on a function, either way. So if I say f of x read as order of g of x, can you please write in the chat box what is the definition for when we say f of x is order of g of x? What is the definition? Let me see. F of x is order of g of x if and only if there exists, come on, write down the definition and tell me, there exist constants c and n naught. That means c greater than 0, n naught greater than 0. Constant c and n naught. What is the inequality to be satisfied? Very good. There exists constant c and n naught such that the value of the function f of n is less than or equal to c times g of n. This inequality need not be satisfied always. Need not be this need not be true always. But whenever, sorry, here we should say f of x. We are writing x here. Whenever, come on, x is greater than n naught. Right? X is greater than n naught. Greater than n naught to infinity, that is the meaning of asymptotic. Greater than, starting from threshold n naught up to infinity, if this inequality is satisfied, then I can claim that basically f of x is order of g of x. F of x should be less than or equal to c times g of x. इसका मतलब ये है in simple terms, if you are given a function f of x, please understand, if you want to find the order of it, means you have to find another function g of x. मैं simple terms में आपको समझा रहा हूँ. If you are given a function f of x, अब अगर आप उसका upper bound function find out करना चाह रहे हो, तो you have to find another function g of x which satisfy this inequality under these constraints. That some constant, there exists some constant, there exists constant, some constants, such that this inequality is satisfied under these circumstances. Whenever x is greater than n naught onwards to infinity, if you are able to prove this, then definitely I say that f of x is order of g of x. f of x, sometime people write belongs to g of x. तो मतलब ये g of x की जो term है, this is a set, you can have a set of functions. So f of x belong to that set basically. Right? Basically belong to that. This can be shown graphically. मैं आगे भी आऊँगा, आगे बताऊँगा आपको graphical representation or graphical meaning of this. So say for example, if I have a function f of, हमारा previous function लेंगे हम, f of n is equal to n square plus n plus 1. What is the order of this function? Come on, very simple. Based on the definition, what is the order of this function? Order of this function is order of n square. कैसे बोलेंगे आप? We can simply write like this. N square is definitely less than or equal to n square. N square plus n will be definitely less than n square plus n square. N square plus n plus 1 will be definitely less than another term n square. So this is my function f of n, n square plus n plus 1. I can definitely prove that is less than 3n square whenever n is greater than 1. Is it not? So if I apply the definition, this is my function f, this is my constant c, and this is my function g. Right? This is my function g. So from here I say f is order of g. That means when we write the order, we don't write the constant. That is the characteristic of asymptotic notation. You know it. So therefore, this is order of n square. Yes, Shifu Khadir, I am coming to that. Can I say, answer me, can I say, is this also order of n cube? मैंने कहा, this is a set of functions. G, order of, is a set of functions. So can I say f of n is order of g of n, order of n cube? Is it true or not? Come on. Can I say f of n, n square plus n plus 1, is it order of n cube also? Yes, it is order of n cube. क्यों? We can easily prove that n square plus n plus 1 will be less than some c into n cube. It is always true. N cube is a bigger function. तो जितने भी बिगर फंक्शंस होंगे, n क्यूब है, n पावर 4 है, n पावर 5, f of n विल बी ऑर्डर ऑफ दैट सेट ऑफ फंक्शंस, f of n बिलोंग टू दैट. तो माय डियर स्टूडेंट्स, आपको ये बताना चाह रहा हूं कि when you are determining the upper bound, I can have many upper bound functions that the function can satisfy, that the function can belong to. लेकिन among all those functions g of n, which f of n belongs to as a group, we should take always that function as far as time complexity is concerned, as far as time or space complexity is concerned, we should determine that function gn. ये बहुत important point है, remember कीजिएगा. Whenever you are determining the upper bound of a function for time complexity purpose, not for mathematical perception, time complexity perspective or space complexity perspective, right? Whenever you are determining the function g of n, you should determine that g which is asymptotically closest to the given function. यहाँ पे मैं point लिख दूंगा मैं, so that you don't go into confusion, right? In determining the bounds, as an important point, in determining the bounds upper or lower of the functions, always determine that function or use that function बोलेंगे हम, always use that function g of n which is asymptotically tight to the given function. क्यों? जब मुझे पता है कि टाइम n स्क्वायर में कंप्लीट हो जाएगा, तो why should I say n क्यूब? आज जब मुझे पता है मुझे यहां से उस प्लेस पे जाने के लिए मैं 20 मिनट में पहुंच सकता हूं, तो मुझे चाहिए मैं 20 मिनट कहूं. मैं ये ना कहूं कि सर आई कैन रीच देयर विद इन 1 आवर. वो लॉजिकली करेक्ट है. इफ आई एम एबल टू रीच विद इन 20 मिनट्स, तो इंग्लिश स्टेटमेंट व्हेन आई से आई कैन रीच विद इन 1 आवर इज आल्सो करेक्ट. लेकिन दोनों में बहुत अच्छा, मतलब रिस्पॉन्स किसका अच्छा है? आई से 20 मिनट्स इज बेटर. Because when I know my algorithm can complete within 20 minutes, I should say within 20 minutes, I should not say 1 hour. तो इसीलिए रीजन है, you should always determine that function which is asymptotically closer. तो मेरा जो फंक्शन था fn n square plus n plus 1 is order of n square, is also order of n cube, is also order of n power 4. ये सब सही है. लेकिन when I say with respect to time complexity, it is more appropriate to say it is order of n square. Most appropriate. वरना definition wise mathematically all are correct. Mathematically all are correct. ठीक है? ये बात हमेशा आप माइंड में रखिए. For any bound, lower हो या upper हो या whatever, you should always determine that function g of n which is asymptotically closer to the given function. तो ये तो हो गया आपका बिगो नोटेशन, अपर बाउंड. उसी तरह हम लोअर बाउंड भी डिफाइन कर देंगे. फिर उसके बाद मैं ग्राफिकली आपको बताऊंगा लोअर बाउंड. ओमेगा represented by this symbol. Definition वही होगा, just inequality change होगी. f of n is omega of g of n. If and only if, right? There exist some constants c and n naught, same thing, such that the value of the function f of n is greater than or equal to c times g of n whenever n is greater than n naught. n is greater than n naught. Just यहाँ पर greater than or equal to हो जाएगा. That is the lower bound concept. तो similarly example हम लेके जल्दी आगे बढ़ेंगे. Same example, f of n is equal to n square plus n. हमारा जो algorithm का time था, we want to find the lower bound time for this case of input, n square plus n plus 1. Okay? This is the concept, n square plus n plus 1. So what is the lower bound of this? I can definitely say that this is greater than what? Come on, first you tell, before I write down, what are the lower bounds of this function? Neha Mishra is saying n square. N. Yeah, that's what I'm concerned. Satyam Binayak is saying n. Shifu Qadir is saying 1. All are correct. All are correct. Please observe, same point. I can say first I can say that n square plus n plus 1 is definitely greater than 1. Therefore, this is omega of 1. Absolutely right. But second point, n square plus n plus 1 is also greater than n. So therefore it is omega of n also. This is also right. This is also right. देख लीजिए बच्चों. Third point, n square plus n plus 1 is also greater than n square. 1 into n square whenever n is greater than 1. So now if you observe this, if you map this to the definition, this is my c, this is my function g, this is my n naught. So it is obeying the inequality. So with this I can say this is also omega of n square. Constants are different, and in the notation representation we don't write the constants. मैं बार बार कह रहा हूँ. So it is omega of n square. So mathematically this function is omega of 1, mathematically this function is omega of n, mathematically this is also omega of n square. लेकिन जब हम time complexity की बात करेंगे, so which is asymptotically more closer to the given function? Is it closer to 1, or is 1 closer to it, or n closer to it, or n square is closer to it? Which one is closer? Closer is n square. Closer is n square. Yes, closer is n square. So therefore from algorithmic perspective, the omega of this is omega of n square. Omega of n square. Omega of n square. ठीक है. उसी तरह अगर मैं और एक एग्जाम्पल आपको लिख देता यहां पर, अगर आपका फंक्शन होता मान लीजिए n plus log n. Please answer this. What is order of this function? What is omega of this function? Come on, boys and girls. Yes. एक और एक सिंपल एग्जाम्पल ले रहा हूं मैं. n plus log n. What is order of it? What is omega of it by definition? Come on. Order and omega is what of this function? Order of n. Come on, write in notation, correct. Order of n. क्यों? क्योंकि n plus log n definitely I can say is less than n plus n, 2n. So it is matching. This is my c, this is my g. What about omega? What about omega? Omega is also n, because n plus log n is greater than 1 into n. Again, I am not concentrating here on simplicity. For simplicity, I am not concentrating on the values of n naught and c. Just concentrating on the functions. So n plus log n is greater than 1 into n. So therefore it is omega of n. Therefore it is omega of n. उसी तरह अगर मैं एक और एक फंक्शन देता, फॉर एग्जाम्पल see on board. Third function. If I say f of n is equal to 2 power 100, what is order of this? What is omega of this? Important. What is order of this and what is omega of it? Come on. 2 power 100. Some value 2 power 100. What is order of it and what is omega of it? Satyam B Nayak, SY. Very good, very good, very good. कैसे बोलेंगे आप? Very simple. Both are order of 1. कैसे? 2 power 100 will be definitely less than another function 3 power 100 into 1. So this is my constant c, this is my function g. And likewise I can say 2 power 100 is definitely greater than 100 into 1. So this is my constant c, this is my function g. Therefore it is order of 1. Implies that any constant c is always order of 1. Remember this. Any constant c is order of 1. ठीक है. अब थर्ड नोटेशन पे आ जाएंगे. थीटा नोटेशन. Theta notation. Side bound. When do I say theta f of n is theta of g of n? N is the input. If and only if. When do I say f of n is order of g of n? And f of n is omega of g of n. जब दोनों अपर एंड लोअर बाउंड सेम फंक्शन होंगे तो जब हम बोलेंगे थीटा नोटेशन. लाइक एग्जांपल फ्रॉम प्रीवियस एग्जांपल, व्हेन आई हैव टेकन f of n is equal to n square plus n plus 1, it is order of n square, it is omega of n square. So therefore we say it is theta of n square. जब अपर बाउंड और लोअर बाउंड दोनों सेम फंक्शन होंगे तो बेटर टू राइट थीटा. मतलब अलगोरिथम एग्जैक्टली उतना टाइम ही लेगा, ये मतलब है. It is not going to take more or not going to take less. That is theta. अगर आप डायग्रामेटिकली देखेंगे तो f of n is less than or equal to c1 times g of n and is less greater than or equal to c2 times of g of n. g of n सेम फंक्शन है, कांस्टेंट्स अलग है, देख लीजिए आप. This is inequality for theta. This is inequality for theta. Again the same constant, if there exists some constant c1 and c2 for whenever n is greater than k onwards to infinity. So that is the meaning of these three notations. इसका डेफिनेशन भी यहाँ पर डायग्रामेटिकली है मेरे पास, आप देख सकते हैं. दिस इज द डेफिनेशन डायग्रामेटिकली फॉर बिगो. ये बिगो का डेफिनेशन है, यहाँ पर देख लीजिए प्लीज. डायग्रामेटिकली यू कैन अंडरस्टैंड, ग्राफिकली यू कैन अंडरस्टैंड. दिस इज इनपुट साइज n growing in the direction and this is the threshold n naught. 0 to n naught the behavior of the two function. ये behavior है f of n, ये behavior है c into g of n का. So 0 to n naught, there is no convergence between the two functions, proper convergence. Sometimes this is more, sometimes this is less. So the behavior of the two functions is not clearly defined from 0 to n naught. लेकिन n naught के आगे से up to infinity, f of n is always less than or equal to c times g of n. So that is why it is called f is order of g. f is order of g. ये है graphical representation. और now upper bound, we use big O notation for a given function g of n. We denote by order of g of f of n is order of g of n. उसका मतलब क्या है, देखिए आप. is the set of functions जो मैंने अभी बताया. Some just order of g of n means it is a set of functions. Order of g of n is a set of functions such that this inequality is satisfied. F of n, there exists positive constant c and n naught such that f of n is greater than or equal to 0 and less than or equal to c times g of n for all n greater than n naught. This is the meaning. So order of g of n is a set of functions. Remember that always. Which satisfy this condition. उसी तरह this is the definition of omega of g of n. Just quite opposite. 0 to n naught, there is no proper convergence between the two functions. लेकिन n naught के बाद से up to infinity, basically c of g f of n is always greater than or equal to c times g of n. This is omega. Theta का उसी तरह. Sorry, this is a theta notation. F of n is theta of g. So f of n is lying between c1 of g and less than c2 of g. So that is theta notation. Right? The n naught is must be small input size. Yeah, n naught is generally small, but it can, as per mathematical definition, this n naught can be anything as such. Sometime it can be 100, sometime it can be 1000, sometime it can be 1 lakh also. अगर 1 lakh के बाद से भी अगर वो inequality exhibit कर रहा है तब भी हम order बोलेंगे. So please understand, there is no hard and fast rule that n naught should be only within this range of values. नहीं, ऐसा नहीं है. It can be 1, it can be 10, it can be 1000, it can be anything. It can be anything. Right? एक सिंपल पॉइंट यहां पर मैं आपको जनरली प्रॉब्लम सॉल्विंग आसान होने के लिए जनरली बताता हूं कि ऑलवेज रिमेंबर द पॉइंट, स्मॉलर फंक्शंस आर जनरली इन द ऑर्डर ऑफ बिगर फंक्शंस. ये आप हमेशा माइंड में रखिए. मतलब जब कोई भी फंक्शन दिए गए हैं, आपको ये मैथमेटिकल इंट्यूटिवनेस होना चाहिए कि विच इज अ स्मॉलर फंक्शन, विच इज अ लार्जर फंक्शन. जैसे मैं अगर बता रहा हूं बात, सिंपल एग्जांपल, n और n स्क्वायर, आपको पता है n इज अ स्मॉलर फंक्शन देन n स्क्वायर. आई डोंट हैव टू टेल यू, आई डोंट हैव टू प्रूव, राइट? सो n इज लेस देन n स्क्वायर. उसी तरह अगर मैं दे दूं log n एंड log n, तो आपको पता होना चाहिए विच इज अ स्मॉलर फंक्शन. log n इज स्मॉलर देन log n. ठीक है? 1 by n and log n, which is a greater function and which is a smaller function. Log n is a greater function than 1 by n. Log n is an increasing function and 1 by n is a decreasing function. तो मैंने इसलिए पिछले लेक्चर में आपको कहा था कि मैथमेटिकल बेसिक्स ऑफ फंक्शंस आपको आना चाहिए. आपको पता होना चाहिए कि कौन सा फंक्शन ग्रेटर है, कौन सा फंक्शन स्मॉलर है. और एक एग्जांपल लेके पूछूंगा, आप बताइए प्लीज. रूट ऑफ log n एंड log n. चलिए बताइए मुझे चैट विंडो में, which is greater among these two? Which is greater among these two? Root log n and log n. Simple mathematics. Among these two, root log n and log n, which is a greater function? देखेंगे कौन बोलेगा. Root log n is greater. Yes, very correct. Very correct. Very correct. No, Vivekananda, both are not same. You can prove it mathematically. Root log n is greater. Root log n is greater than log n. How? Take log of both. You get the answer. You take log of both, you get the answer. ठीक है? So always remember, smaller functions are generally in the order big O of bigger functions. Second, इसका opposite, bigger functions are omega of smaller functions. If the rate of growth of both functions are same, if the rate of growth of both are same, theta. Right? Theta. Order of n and omega of n, where n is different for both. What do you mean by n different for both? That I don't get. n is different for both का मतलब क्या है? ऐसा तो नहीं होता. n is increasing function. Input है आपका n. You cannot say both are different. Okay? चलिए. Abhi, before I take up some problems on this, we will see very quickly small notations. एक स्टेटमेंट लिखूंगा मैं, why should I go for small notations? यहां पर हम लिखेंगे the bounds upper or lower, right? Upper or lower bounds provided by big notations. That is big O and big omega, big notations. May or may not be tight. May or may not be tight. ये बात तो समझ में आ गई? The bounds provided by big notation, big O or big omega, may or may not be tight. मतलब अगर मैं एक फंक्शन लिखूं f of n is equal to n, इसका big O क्या है? Order of n और order of n square, ये भी हो सकता है. Order of n log n, ये भी हो सकता है. So my dear students, ये तीन functions में I would like to emphasize that this is tight and these two are loose, not tight. तो वही कह रहा है, the bounds provided by big notation may be tight, may not be tight. लेकिन यहां पर हम लिखेंगे but bounds provided by little or small notations is always not tight. Little or small notations is always not tight. ये बेसिस पर हम डिफाइन करेंगे स्मॉल o, फोर्थ नोटेशन स्मॉल o. क्या है? वी राइट f of n small o of g of n if and only if for all for all constants c greater than 0 and n naught, f of n is less than c times g of n. Whenever n is greater than n naught, same thing. The only change is this. We have only less than, loose bound, not tight. Second difference is, in the case of big O, I have for there exists some constant c. अगर कोई constant exist हो रहा हो, यहाँ पर कोई नहीं, हर constant c. For every value of c, for all c greater than 0, it should satisfy this inequality. तो मतलब ये हुआ कि if I take for example a function f of n is equal to n, if I want to find the small o, I should find that function which is always superior, which is always greater than this, right? That means maybe I can say n square, maybe I can say n cube is correct, but when I say small o of n, it is wrong. It is wrong because this is asymptotically tight, this is not loose. Bound provided by small o is always not tight, so that is the difference. It is big O. Every small o is big O, but every big O is not small o. देखिए आप, this is big O, but it is not small o, right? So every small o is big O, but every big O is not small o. So big O is a bigger space than small o. That is what I am trying to say. उसी तरह इसका opposite definition अगर आप लिखें, if you try to write for small omega here, see on board. Fifth notation. When we say f of n is equal to, f of n is small o, small omega of g of n, if and only if for all c greater than 0 and n naught greater than 1, f of n is greater than c times g of n. This point you have to remember whenever n is greater than 1. Right? So we write, like, for example, if I have a function f of n is equal to n square, we say big omega is n square, true. Big omega of n, true. But when it comes to small omega, it is small omega of n, right? Small omega, this is correct. Small omega of n square is wrong. This is the point. Every big omega is small omega is false. Every small omega is big omega is true. Like that. Yeah, log n also can be taken. N square is greater than log n. That is correct. So this is the thing. Now finally, before I come to the problem solving part, I would like to tell a very important relation as per the Corman textbook, which is a analogy between asymptotic notations and real numbers. Suppose if I say f and g are functions, positive functions, a and b are two real numbers, then what is the analogy between them? The first analogy is, when I say that f of n is order of g of n, it is as good as saying what relation should be there between a and b. The relation between them should be that a is less than or equal to b. Suhail Khan, you are right. F of n is strictly greater than cgn. Then second analogy for big omega of g of n, when I say, it is as good as equivalently saying that a is greater than or equal to b. Third, when I say f of n is theta of g of n, analogously this is same as saying what? A is equal to b. And when I say, for example, f of n is small o of g of n, a is less than b, strictly less than. F of n is small omega of g of n, then analogously this means a is greater than b. These are the properties. Analogous relation between the asymptotic notations and real numbers. Here remember kijiye. So you will never go wrong. When I say big O means it is less than or equal to, greater than or equal to, less than, greater than. That's it. ये आप हमेशा याद रखिए. और ये बात हमेशा ये भी याद रखिए कि smaller functions are order of bigger. Bigger are omega of small. Bigger is omega of smaller function. That's it. You will never go wrong. अगर दोनों के functions का rate of growth same है, then basically theta a equal to b. Okay. So last point before I would like to start the problem solving, यहाँ पर एक graph के basis पे मैं आपको बताना चाह रहा हूँ. When I say that the time complexity is being represented by means of a mathematical function like f of n or t of n, then what kind of functions generally can we get? Generally, mathematically, we divide the functions into two categories. One is called the polynomial functions, and the other is exponential functions. Polynomial functions also include in its space logarithms. I am not explicitly writing, so I am making an assumption that logarithms also come in the class of polynomials, and the other is exponential. So general form of a polynomial is like n power x. X may be greater than or equal to 0. And exponential form is like, for example, a power n when a is greater than 1. ये दोनों functions में कौन सी category of function की rate of growth ज़्यादा होगी? Exponentials have higher rate of growth. Exponentials have higher or superior rate of growth. मतलब ये ज़्यादा time लेंगे for a given value of n. Right? Exponential have higher rate of growth. मतलब अगर कोई भी algorithm की मेरी complexity exponential आई तो ज़्यादा time लेगा. Means algorithm run slow. ये reverse concept है. This has slower rate of growth. Slower rate of growth. मतलब they take less time. Means algorithm run fast. इसका मतलब ये हुआ कि whenever we develop algorithm, whenever we want to develop an algorithm for a problem, we always expect the algorithm to have polynomial rate of growth or exponential polynomial. Why? Polynomial have lesser rate of growth means algorithm would run faster, right? So this is the point you have to basically always keep in mind. Just for a sort of illustration here, I am showing you in the graph, right, by means of this graph taken from Wikipedia, showing the rate of growth of the function. These are constant. The pink one is a constant. Rate of growth of log n, rate of growth of root n. Root n is greater than log n, right? Then I have this function n, linear for example. Then n log n, then n square, 2 power n, n factorial, that is n power n. That is a concept. Yes, constants also come in the polynomial category. एक ही rate of growth है उसका. That's why constant is here 1. This line is constant. Is log n, root n, n log n, n square, like that. So based on this, I can propose what I call it as a dominance relation among the function. Dominance relation among the functions. Like I can have constant asymptotically a. A means asymptotically less than logarithms. Log is less than n. That means poly we will write, poly. Less than, asymptotically less, exponential. Like for example, any constant is less than log n, less than n log n, or maybe n I can write like this, less than n log n, less than n square, less than n cube, less than so on, 2 power n, 4 power n, n power n. Dominance relation of the functions. So therefore, here I would say log n is less than n, means log n is order of n is order of n log n is order of n square is order of n cube, इस तरीके से. तो जब भी कोई भी आपको एक फंक्शन दिया जाए, you have to see where this function fit in this dominance relation. कहाँ fit होगा? Accordingly you can say is it order or omega or this. That is one approach you can use for solving. ठीक है? Come on, work out this problem first. Quickly, I'll give you 1 minute of time. कुछ functions दिए गए हैं. This is my first category of problems. State true or false. Many of the bits of this are from previous papers of GATE. Come on, boys and girls, let me see. Work out this on your own and then check your answers with me. Check your answers. Check your understanding. Put all your answers. Because some questions are given, which among the following is true or which among them is false. 4 options will be given. You have to pick up the correct one, you have to pick up the incorrect one, that way. चलिए मैं ऐसा करूंगा, which of them are true, या तो आप पूरे true लिख दीजिए, 1 2 3 4 5 are true, 6 7 8 are false, इस तरीके से लिखे, या आप खाली नंबर्स के साथ जितने false है वो लिख दीजिए, देखेंगे. You write either true or you write either false, so that you can compare it. SY 1 is true, second is true, third is false, fourth is true. Okay, ठीक है, आगे भी करिए. Come on, this is interesting. Problem solving है, बहुत interesting है, करिए please. ओके ठीक है, 2 मिनट में बैठ जाऊंगा, चलिए देखेंगे। Come on, boys and girls, take it as a matter of practice and do it. Majority of the bits of these are from previous paper of GATE that basically test your basic understanding of functions. Very good, people are working. Very good. चलिए स्टार्ट करेंगे, वन बाय वन विल टेक एंड सी. First, 100 n log n, these constants, so therefore the order of n log n, perfectly correct. 2 power n plus 1 can be written as 2 into 2 power n, these constants, so therefore the order of 2 power n, perfectly correct. यहां पर जनरली स्टूडेंट कंफ्यूज होते हैं. जस्ट टेल मी थर्ड वन, इज इट ट्रू और फॉल्स? थर्ड का बता दिए, सिर्फ एक, 2 power 2n, बेसिक अंडरस्टैंडिंग ऑफ मैथ्स. थर्ड वन, इज इट ट्रू और फॉल्स? थर्ड वन, इज इट ट्रू और फॉल्स? मैं पूछ रहा हूं सिर्फ थर्ड का बताइए, ट्रू और फॉल्स? फॉल्स. वेरी गुड. व्हाई इज इट फॉल्स? विवेकानंदा इज सेइंग फॉर ट्रू. सम पीपल आर सेइंग, मोहित इज आल्सो सेइंग ट्रू, परशुराम इज आल्सो सेइंग ट्रू. देखिए गलती हो गई आपसे, गलत कर रहे हो, प्लीज. Why is it true? Why is it false? देखिए, दिस फंक्शन यहां पर लिख रहा हूं मैं, 2 power 2n is nothing but 2 raised to 2 whole raised to n, which is 4 power n. 4 power n. और अदर हमारा दूसरा फंक्शन है 2 power n. 4 power n is greater than 2 power n, naturally. 4 power n is greater than 2 power n. So therefore 4 power n cannot be order of 2 power n. This is a greater function, this is a smaller function, this is greater, this is smaller. Greater function cannot be in the order of smaller function. Smaller function is in the order of greater. So therefore this is wrong. This is false. ठीक है? Very good. 0 is less than x less than y. N power x polynomial is order of n power y. Very much true. N square is less than n cube, for example. Very correct. N plus k power m is theta of, is not equal to theta of n power m. Is it true or false? Very good. Very good. Fifth one, is it true or false? Fifth one बताइए मुझे. Fifth one is false. Very correct. Because if I write like n plus 4 whole square, a square plus b square, this is n square plus 8n plus 16. This is order of n square. And this is omega of n square. Very correct. So therefore this is theta of n square. Is theta of n square. So n plus k power m is a polynomial of degree m. So therefore this theta of n power m not equal to is false. Equal to is true. Not equal to is false. अभी मैंने कहा था, थोड़ी देर पहले ही बताया था, रूट लॉग एन इज ग्रेटर देन लॉग लॉग एन. रूट लॉग एन इज ग्रेटर देन लॉग लॉग एन. फिर से एक बार लिख रहा हूं मैं आपको, रूट लॉग एन इज ग्रेटर देन लॉग लॉग एन. कैसे? वेरी सिंपल. जब भी कोई आपको दो फंक्शंस में कंफ्यूजन होना, यू टेक लॉग ऑफ दिस. इफ आई टेक लॉग ऑफ रूट लॉग एन, log of root log n, I can write it like log n power half. और यहां इसका log अगर ले लूं तो it become log of log n, like this. So this become half log log n, और ये है log n. या n पे हम 3 टाइम log अप्लाई कर रहे हैं, या n पे हम 2 टाइम log अप्लाई कर रहे हैं. This is greater naturally. So therefore it is order of this is false. ये false है. log n is omega of 1 by n, true or false? log n is greater than 1 by n, अभी हमने कहा, so therefore this is true. ये देखिए, 2 power n square is order of n factorial. come on. तो उसके लिए सबसे पहले आपको पता होना चाहिए what is n factorial order of. n factorial is order of n power n, आपको पता हो. कैसे? n factorial is n into n minus 1 into n minus 2 so on up to 1 is definitely less than n into n into n into n so on. n is less than n power n. So always remember, n factorial is order of n power n. n factorial is order of n power n. तो देखिए आप 2 power n, 8 का बताइए मुझे बॉयज एंड गर्ल्स. 2 power n square is order of n power n, true or false? 8 का false or true? come on. SY, Suhail Khan, Bhagwadhari, Satyam. 8-1, true or false? Some people are saying true, some people are saying false. Very simple. 8-1 is false. 8-1 is false because देखिए आप दो फंक्शंस है 2 power n square and the other is n factorial is order of n power n. हम ऐसा n factorial को ऐसा लिख देंगे. If I take log of both, this become n square into log 2 to base 2 and this become n into log n. Log 2 to base 2 is 1, so this value is n square and this value is n log n. तो मतलब ये हुआ n square is greater than n log n. So therefore this function is greater than n power n, so therefore this is false. 9th one, n square is 2 power 2 log n. What is 2 power 2 log n? Using property of log. Using property of log, मैं थोड़ा इसको रब कर दूंगा. Using property of log, 2 power 2 log n is how much? This is nothing but first I can write it like 2 power log n square to base 2, which I can write it like n square whole power log 2 to base 2. Log 2 to base 2 is 1, so therefore this is n square. 2 power 2 log n is n square. So therefore n square is order of n square, correct. 10th one, a power n is not order of n power x. X is greater than 0, a is greater than 1. A power n is an exponential function, cannot be order of polynomial function. This is true. And this is again a repetition of what we did just now, so this is also true. So इस तरीके के is one type of question which can be asked in the exam, which have been asked. So इसकी familiarity के लिए, इसमें आपकी proficiency improve करने के लिए what is required is your basics of mathematics. जो मैंने पिछली क्लास में कहा था, आपको mathematical ability होना चाहिए, properties of log, exponential concepts, ठीक है, summation series का भी importance है, तो वो basis पर आप ये problem solve कर सकते हैं. चलिए ये problem solve कर लीजिए. Comparisons, मतलब यहां पर आपको ये बताना है, you are given two functions. This is another model of questions. You have to say which function is in the order of the other. Which function is in the order of the other function. Like for example, एक पहला हम कर लेंगे, फिर वो बेसिस पे आप बोलिए. In this case, f of n is n, g of n is log n. So therefore definitely I say that g of n is order of f of n. क्यों? G is a smaller function than f. 100% Shifu Qadri. Polynomials are in the order of exponential always. Polynomials is always in the order of exponentials. Logarithms are always in the order of polynomials. Next, second function के लिए बताइए please. Come on, work out for second function and tell, is f order of g or g order of f? Come on, boys and girls, these are interesting questions. Second one, g is order of f or f is order of g. Okay, चलिए solve करेंगे. We have f of n is equal to n square log n. Please see boys and girls. And the other function g of n is n into log n whole raised to 10. ऐसा मतलब है. The common factor in both is n log n. I can write the first function as n log n into n, and here I can write it like n log n into log n whole raised to 9. तो ये तो कॉमन है दोनों में. यहां पे बच जाएगा n और यहां पे बच जाएगा log n whole raised to 9. तो ये दोनों में आपको कंपेयर करनी है कि कौन सा फंक्शन ग्रेटर है. तो आपको मैंने क्या कहा, अगर जहां पर भी आपको डाउट हो आप लॉग ले लीजिए. अगर ये फंक्शन का हम लॉग लेंगे तो दिस विल बिकम log n और ये बन जाएगा 9 times log n. So for large values of n, 9 become ignorable, so therefore this is greater. F is greater than g, matlab like earlier occasion, g of n is order of f of n. G of n is order of f of n. G is a smaller function than f. चलिए third question work out कीजिए please. Third question. That is also an interesting one. Third one. Third one is a gate question. In fact, second was also a gate question. Third one, you are saying F is order of G. F is order of G. Okay, very good. ठीक है. That is very simple. F of n from 0 to 10,000 is n cube, लेकिन 10,000 के बाद से क्या हो रहा है? It is becoming n. उसकी rate of growth कम हो रही है. Right? Yes, log you can almost apply to every function, please. Then g of n from 0 to 100 is n, लेकिन 100 के बाद से इसकी rate of growth बढ़ जा रही है n cube. So very clear, therefore, this function can we say that f of n is order of g of n. लेकिन एक मेरा क्वेश्चन ये है, what is the smallest integer k? Because this should be satisfied for some n greater than k or n greater than n naught generally. n naught हमारा कन्वेंशन था n naught. तो यहां पर कोई मुझे बता सकता है what is the smallest value of n naught? This is an interesting question. What is the smallest value of n naught? What is the smallest value of n naught in this? From where I establish the fact that f of n is order of g of n. ये बहुत important है. What is the value of n naught? From where I say that f of n is order of g of n. This is very interesting. What is the smallest value of n naught? Satyam Binayak is saying 100. Logical learner is saying 10,000. Come on, what about other people? SY 10,000 or 100? यही है conflict. ये gate question नहीं है. Is it 100 or 1000? 10,000. 10,000, not 1,000. 10,000 or 100? That is the question. 100 is the correct answer. 100 is the correct answer. क्योंकि 100 पे भी देखिए आप 0 to 100 is n cube is order of n cube, correct? And beyond 10,000 it is of course order of that. So आप 10,000 से पहले 100 से भी आप कर सकते हैं कि f is order of g and g is order of f up to 10,000. और 10,000 के बाद तो definitely f is order of g. That's it. So therefore, smallest value of n naught, from where I can say that f is order of g is 100, not 10,000. Smallest. 10,000 से तो रहेगा पक्का. 100 से भी रहता है, ये कह रहा हूं मैं आपको. 100 से भी रहता है. ठीक है, ये क्वेश्चन लूंगा मैं. ये फंक्शंस को अरेंज देम इन इंक्रीजिंग ऑर्डर ऑफ रेट ऑफ ग्रोथ. कम ऑन, अरेंज दिस फंक्शंस इन इंक्रीजिंग ऑर्डर्स ऑफ रेट्स ऑफ ग्रोथ. ये भी आपको एक टेस्ट करेंगे कि यू कैन टेस्ट योरसेल्फ ability of mathematical ability to decide which function is smaller and which function is greater. Ankit Singh, देखिए दो approaches है. One approach is if you want to compare two functions f and g, first approach is take log. Second, substitute the values of n. Take some values of n and substitute in the function. लेकिन ये क्या होता है, ये बहुत मतलब वेग अप्रोच हो जाएगा. लॉग मोस्ट ऑफन फॉर मोस्ट ऑफ द फंक्शन, मोस्ट ऑफ द टाइम आप लॉग से कर सकते हो, लेकिन अगर कुछ स्पेशल फंक्शंस है लॉग से अगर मुश्किल हो रही हो तो आप फिर n के वैल्यूज, लार्ज वैल्यूज ऑफ n आप फंक्शन में सब्स्टिट्यूट करके आप चेक कर सकते हो. ठीक है, कम ऑन, वर्क आउट दिस. आई विल गिव यू 2 minutes ऑफ टाइम. लॉग इज बेटर ऑलवेज. और इसीलिए मैं कहा कि आपको मैथमेटिकल परसेप्शन आना चाहिए, मैथमेटिकल इंट्यूटिवनेस आना चाहिए टू डिसाइड विच इज ग्रेटर एंड विच इज स्मॉलर फंक्शन. ये इट ऑल डिपेंड्स ऑन योर मैथमेटिकल एबिलिटी. जितने आप स्ट्रांग हो मैथमेटिक्स में उतना फास्टर आप डिटरमिन कर सकते हो, कंपेयर कर सकते हो फंक्शंस को. देयर इज नो हार्ड एंड फास्ट रूल. चलिए बॉयज एंड गर्ल्स, फर्स्ट वन इज वेरी सिंपल. दिस फंक्शन इज polynomial. This is also polynomial. This is also polynomial. This is exponential. This is polynomial. This is exponential. This is again in the category of polynomial. तो इसका इंक्रीजिंग ऑर्डर कैसे होगा, जल्दी लिख के बताइए मुझे. फर्स्ट फंक्शन का इंक्रीजिंग ऑर्डर कैसे होगा? सबसे पहले हम डालेंगे 1/n लेस देन, कौन सा आएगा उसके बाद, पॉलिनोमियल्स में डिसाइड कर लीजिए। आई हैव n लेस देन n log n लेस देन n root n लेस देन n स्क्वायर, पूरे आ गए फंक्शन 1 2 3 4 5, 1 2 3 4 5 एक्सपोनेंशियल्स e पावर n और 2 पावर n। e की वैल्यू क्या है कांस्टेंट की, 2.7 समथिंग, तो और ये है 2, so therefore less than 2 power n less than e power n, that's it. This is the increasing order of the functions. उसी तरह ये सेकंड में देखिए आप क्या है, दिस पॉलिनोमियल, दिस पॉलिनोमियल, दिस एक्सपोनेंशियल, ये आप थोड़ा कंफ्यूजन दिख रहा है आपको, दिस इज फंक्शन इज n पावर log n, अगेन एक्सपोनेंशियल लाइक n पावर log n। तो कैसे करेंगे आप पॉलिनोमियल में, टू फंक्शंस जो है फंक्शंस आप कंपेयर करेंगे, n पावर 3/2 एंड द अदर इज n log n। तो यहां पे डिसाइड करनी है आपको विच इज ग्रेटर, विच इज ग्रेटर, कम ऑन बॉयज एंड गर्ल्स, n power 3/2 and n log n, which is greater function among them? n power 3/2 and n log n, which is greater? n log n is greater, n power 3/2 is greater, क्यों? क्योंकि this is n power 1.5 which is n root n, n root n is always greater than n log n, n root n is always greater than n log n। तो सबसे पहले आएगा n log n, मैं यहां पे नहीं लिख रहा हूं, n log n, फिर n power 3/2, फिर 2 पावर n और n पावर log n में देखिए आप, अगर दो फंक्शंस है 2 पावर n एंड n पावर log n, विच इज ग्रेटर, विच इज ग्रेटर, टेक log ऑफ बोथ, अगर इसका आप log लेंगे दिस विल बिकम n इंटू log 2, log 2 to base 2, this will become log n into log n to base 2। So I have got to compare between n and log n to base power 2, so therefore asymptotically this is greater, asymptotically n is greater than log n power 2, so therefore I would say 2 power n is greater than n log n, मतलब पहले ये आएगा n log n, फिर n power 3/2 less than n power log n and less than 2 power n, 2 power n आखिरी में आएगा, ठीक है, दिस ओके। उसी तरह दिस यू कैन वर्क आउट एज अ होमवर्क, I mean you can do it on your own, that's not a big challenge, you can do it, right? ठीक है, चलिए लास्ट क्वेश्चन हम ये लेंगे बिफोर वी टर्मिनेट टुडेस क्लास। दिस वाज ए प्रीवियस गेट क्वेश्चन, कम ऑन डू इट प्लीज, ऑप्शंस आर आल्सो गिवन, ऑप्शंस आर आल्सो गिवन, प्लीज वर्क आउट फास्ट एंड टेल मी व्हाट इज आंसर फॉर दिस, व्हाट इज आंसर फॉर दिस। It's a gate question for 1 mark. Increasing order. Just check your understanding. यहाँ पे generally students will make a simple mistake here that I wanted to show you. Correct answer for this question. B. Ankit Singh is saying B. Okay. Okay. Very good. Come on, others also. Neha Mishra, check it again. Muhammad Asif, you are saying A. Bhagwadari is saying B. Okay, fine. Those who are saying other than B, please check it yourself. Very simple. देखिए आप, I have constant root n, n, log n and 100 by n. So which function is having a lowest or slowest rate of growth? Slowest rate of growth will be a decreasing function. This is a decreasing function, please. 1 by n is a decreasing function. क्यों? क्योंकि जैसे जैसे आप value of n, if you keep on increasing, if you keep on increasing the value of n, resultant value 1 by n keeps on decreasing, right? The 1 by n function will be something like this. 10 का तो ऐसा है rate of growth, constant. This is lesser. It is keeps on decreasing. Like this is like 1 by n. This is like constant 10. Others are increasing. Other functions are increasing like this. तो सबसे पहले आएगा 100/n, फिर उसके बाद आएगा 10 कांस्टेंट, फिर उसके बाद आएगा log n, फिर उसके बाद आएगा √n, फिर उसके बाद आएगा n. सो देयरफॉर B इज करेक्ट, वेरी करेक्ट. ठीक है, तो चलिए आज के लिए यहीं पे हम क्लोज करेंगे. इन नेक्स्ट क्लास आई विल टेल यू व्हाट आई एम गोइंग टू डू, राइट. सो इन नेक्स्ट क्लास I will work out few more problems, particularly like determining the time complexity of recursive algorithms or a couple of loop problems, loop complexity. फिर उसके बाद मैं space complexity कैसे determine करेंगे हम देखेंगे. That will be an interesting aspect. आज हमने time complexity की बात की, space complexity की बात हम next lecture में करेंगे. फिर उसके बाद हम नया topic start करेंगे, divide and conquer strategy. तो ठीक है, तो पहले some more problems, few more problems on this, then recursive algorithm time complexity framework, then we will see loop complexities, a couple of questions, right? And then we have basically like space complexity and problems. Then we'll start the chapter on divide and conquer. That will be the thing. Now my class timings are from 6:30 to 8, not like 8:30. Okay, thank you very much for attending. So please practice this and come for the next class. We'll continue in the next class, please. So take care, good night.